CERN physicists observe influence of gravity on antimatter. Physicists from the Alpha collaboration at CERN's Antimatter factory have demonstrated the existence of gravity between antimatter and Earth, reaffirming Albert Einstein's general theory of relativity. Our bodies, the Earth, and most everything else physicists know about in the universe are overwhelmingly made of regular matter consisting of protons, neutrons, and electrons, like atoms of oxygen, carbon, iron, and the other elements of the periodic table. Antimatter, on the other hand, is regular matter's twin, though with some opposite properties. For example, antiprotons have a negative charge while protons have a positive charge. Antielectrons, also known as positrons, are positive while electrons are negative. However, perhaps most challenging for experimenters, as soon as antimatter touches matter, it blows up, said Dr. Joel Fagans, a plasma physicist at the University of California, Berkeley and a member of the Alpha collaboration. The combined mass of matter and antimatter is transformed entirely into energy in a reaction so powerful that scientists call it an annihilation. For a given mass, such annihilations are the densest form of energy release that we know of. But the amount of antimatter used in the Alpha experiment is so small that the energy created by antimatter annihilations is perceptible only to sensitive detectors. Still, we have to manipulate the antimatter very carefully or we will lose it. Einstein's theory of general relativity says antimatter should behave exactly the same as matter, said Dr. Jonathan Werdula, a plasma physicist at the University of California, Berkeley and a member of the Alpha collaboration. Many indirect measurements indicate that gravity interacts with antimatter as expected, but until the result today, nobody had actually performed a direct observation that could rule out, for example, antihydrogen moving upwards as opposed to downwards in a gravitational field. In their experiments, the Alpha physicists trapped groups of about 100 antihydrogen atoms, one group at a time, and then slowly released the atoms over a period of 20 seconds. Computer simulations of the Alpha-G setup indicate that this operation, for matter, would result in about 20% of the atoms exiting through the top of the trap and 80% through the bottom, a difference caused by the downward force of gravity. By averaging the results of 7 release trials, the Alpha team found that the fractions of antiatoms exiting through the top and bottom are in agreement with the expectations from the simulations.